Alright, people, back to trigonometry. Trigonometry is probably the most important subject that we will study this year in terms of what you're going to use in high school math. Trigonometry is going to come up the most out of everything that we've done this year. In geometry, most everything else in geometry is kind of begins and ends with geometry. You don't really study circles and all that kind of stuff much more after you get out of geometry. You do a little bit, but trigonometry comes up a lot. Okay, so basic trigonometry here. SOHCAHTOA, how would we solve for x on this? Would we use sine, cosine, or tangent? Well, hopefully you remember SOHCAHTOA stands for sine is opposite over hypotenuse. We're not using the hypotenuse in this one. We're using the side that's opposite 30 and adjacent to 30. So opposite over adjacent is TOA, SOHCAHTOA, tangent. So this is tangent 30 is equal to 10 over x. And then if you wanted to figure out what x was, which is what we want to do here, how long is that side on the bottom of the triangle, you would multiply, you get x by itself. You would multiply x to the other side to get x in the numerator first. Remember, we're not trying to solve for 1 over x, we're trying to solve for x. So you multiply x to the other side, and you get x tangent 30 is equal to 10. And now we just have to get rid of the tangent 30 and x will be by itself. And to do that, you divide the numerator tangent 30. You divide to the other side when you're multiplying two things together. Do the opposite. So x is equal to 10 divided by tangent 30. All right, so we figured out what x was, 10 divided by tangent 30. And if you have a calculator, then you can punch that in and figure out what the exact length is. All right, that's all review. Now we're going to do something new. Now we're going to solve this problem for a triangle that is not a right triangle. So far with SOHCAHTOA and everything we've done with trigonometry this year, it's always been right triangles. Well, now it's not. So here's a triangle. I'll make it ABC just like the last one, and I'll use 30 degrees, and I'll use 10 across from it, and it would look something like this. All right, now on the last one, we knew what two of the angle measures were. We knew what 30 was, and we also knew that one of the angles was 90 degrees. So that's important. We need to know at least two of the angles here. Well, that's not necessarily true. We need to know three parts. We need to know an angle and a side opposite of it, which is what we have. We have 30 and we have the side opposite of it. That's a prerequisite to use what we're going to use today, which is called law of sines. So that's important. To use law of sines, this is your starting point. Two things. First, it's non-right. So it's not a right triangle when we're going to use law of sines. And second is you have to have at least one angle and the side opposite of it. Side opposite. So those are the two things that you got to have to use law of sines. Is it has to be not a right triangle. This is not a right triangle. And you have to have at least one angle. We do 30 degrees, and you have to have the side that's opposite of that angle, which we do. 10 is across the triangle from 30. So we've got what we need to do law of sines, except we need a third part. It just doesn't matter what that third part is. It could be one of these sides. It could be one of those angles. So there's four parts left on this triangle. Two angles that we don't know, B and C, and two sides that we don't know. We need to know one of them to use law of sines. All right. So let's say we know, this side over here is 15. All right, now what are we going to try and solve for? Well, in the homework tonight, you're going to solve for all three missing parts. You're going to solve for the missing side down here, angle B, and angle C. So there's, I think, 4 problems in the work for today, and they're all multi-step problems. You got to figure out more than one thing for each problem. All right, so let's say we'll start with the side on the bottom, which normally when we're solving for something we call it x, but in law of sines, we're not using x, y, and z. We're using a, b, and c only. We're using capital and lowercase a, b's, and c's. So the capital A, B, and C are your angles, and then the sides opposite of those letters are your lowercase. So 10 would be side lowercase a. 15 would be the side lowercase b because it's across from b. And then this side on the bottom, which is across from the angle C, is little tiny baby c, lowercase c. So the c's are a little confusing because it's sometimes hard to tell which one's capital, which one's lowercase, but the a's and b's are easy. All right, so let's solve for c first. So I'm just going to tell you what the formula is today and solve this problem for you so you can do the work for today. And then tomorrow, after you've done a few problems, I'll show you where this formula actually comes from. But the formula looks like this. Sine of a over a is equal to sine of b over b. And you could substitute out that for sine of c over c, it doesn't matter. But basically the sine of an angle is over the side across from it. So a goes with a, and that's equal to the ratio of sine of b over side b. It's also equal to the ratio of sine of c over side c. So if we want to solve, let's start with angle b here. What is angle b? All right, well, you can erase either sine of a over a or sine of c over c. You only need two fractions to solve these. All right, so let's get rid of sine of c over c because we don't know what those numbers are anyways. We don't know what c is, angle c is, and we don't know what side c is. What we do know is sine of a over a. Sine of a, angle a is 30 and side a is 10. And we know that little side b is 15. And that's what you have to have. When you're trying to solve for a missing measurement and you have a ratio here, a fraction, you got four parts to your fraction, a numerator and a denominator in each one. You got to know three out of those four parts to solve for the fourth one. So we do. We know sine of a is sine of 30, and we know side a is 10, and sine of b, b is what we're trying to solve for, and we know side b is 15. So that's what we've got so far. So that's using law of sines and just substituting in what we know from our problem. We knew three things. We knew a was 30 degrees, side a was 10, and side b was 15. So we substitute that into our formula. This is just algebra. Now we're just going to solve for b. So you're going to try and get b by itself. That means multiply 15 to the other side. So 15 sine 30 over 10 is equal to sine of b. Now you can get out your calculator and do sine of 30, and that'll give you a number, which is probably 0.5 if I remember correctly. And then it'd be 15 times 0.5, which is 7.5, and then divide that by 10, and you would get 0.75. So check with your calculators, but you should get sine of b is equal to 0.75. Now, we're almost there. We want to know what is the angle measure of b. And remember back to when we did trig around Christmas time, right after Christmas break, and we had to find a missing angle. If you want to find what b is, you got to get sine to the other side. And when you separate sine from its angle, it turns into inverse sine, the -1. So it's actually inverse sine to the -1 of 0.75 equals b. So you would type in sine negative, well, it'd be the second sine button, or you guys are probably going to be using scientific calculator apps on the computer. You might even go to Desmos. So you won't have to hit the second button. There'll just be its own button that's inverse sine to the -1. So inverse sine 0.75 equals whatever it equals. That's your angle measure for b. And then you've solved b. Now, once you've solved for b, now you can solve for c and c here. All right, so that's you do this the same, you would just start over and solve for c or c. Now you may say, well, you told us you need to know 3 out of the 4 parts. So say you're trying to solve for angle c, and you use law of sines for angle c, you're making your life way more difficult. Once you solve for 2 out of the 3 angles, remember, triangle sum theorem, you can get the third angle. So I don't know what inverse sine of 0.75 is, but let's just say that it's 40 degrees. And if that's 40 and that's 30, that's 70 degrees. That would make this 110. So now you could do this over again for c. You could use either sine of b over b, or you could use sine of a over a, but you're definitely going to have to use sine of c over c is equal to either one of those, sine of b over b or sine of a over a, and then you'll solve for sine of c the exact same way we did here. All right, and that's it. That's how you solve for angles. Solving for sides is actually a little bit easier. It's almost exactly the same. It's just one less step at the end. You don't have to do the inverse sine. You're going to have the a or the b or the c, the little one all by itself. You won't have to do an inverse. So try and do those for tonight. It's probably going to be a little bit of a disaster because this is a tough subject. So we're going to do this again tomorrow. I lost my cap here. I'm going to do a couple more examples tomorrow that most likely will be the exact same problems off the homework, so you get an idea of what you should have been doing if you're not doing it right already. Hopefully it'll start to click by then. Then I'm also going to eventually explain to you where that formula comes from, which is kind of cool, and maybe that'll all help tie it together and make it make more sense.